So let's take a look at how we might go about solving a problem that uses vertical and horizontal parts. In other words, an angled launch problem. So it looks complicated, but we can use a little bit of math, specifically trigonometry, to help us take a launch problem where V naught is at some angle theta naught and break it into its two parts, just like we will in every projectile problem, into a horizontal and a vertical part. These two parts are called components. So this launch velocity has an x and a y component to it. And we just need a little bit of trig to help us find them. So if we look at a basic crash course in trigonometry here, I know some of you are taking trig right now or taking pre-calculus right now. So I'm going to tell you just what you need to know in order to get by here in terms of what we're doing in physics. So we're going to define three trigonometric functions, the sine, cosine, and tangent, in terms of the sides of a right triangle. So my triangle has three labels or three names to it. We've got a right triangle, a triangle with a 90-degree angle in it, and then another angle theta. So in our projectile motion, theta is going to represent our launch angle. The long side of the triangle is called the hypotenuse. The side that's across from or opposite the angle is the opposite, and then adjacent means next to. So we have our three labels. And perhaps you've seen this mnemonic device before, SOHCAHTOA. Reminds me of what these three trig functions are in terms of the ratio of sides. So the definition of the sine of theta is the opposite side of the triangle divided by the hypotenuse. So sine theta, there should be a button on your calculator, sine theta, will relate these two sides. Now if we think about it in terms of our velocity, the launch velocity will be the hypotenuse, and the opposite side will be the y part of that launch velocity. So sine theta is vy naught over v naught. And therefore I can figure out what amount of my launch velocity is in the y direction by multiplying the launch speed by the sine of the launch angle. Please add this to your equation card. In the same vein, I can go to the cosine function. Cosine is the ca of the SOHCAHTOA, and it's opposite over hypotenuse. Adjacent over hypotenuse. And so in this case, the adjacent side is the x part of the launch velocity. And I can then figure out how much of my launch velocity is in the x direction by multiplying the launch speed times the cosine of the launch angle. Even though you don't have to remember these for the test, you can put them on your equation card. It's worth noting that it's basically alphabetical. So x comes before y in the alphabet, so does c before s. So you can think x for cosine and y for sine in alphabetical order. The third trig function, the tangent function, will occasionally be useful to us. If I happen to know the two pieces of the velocity, so think like the Batman problem where we know his x and y velocity when he hits the seat, the tangent function relates the opposite and adjacent sides, so the y and the x sides. So in your calculator, if you're going to solve that for the angle of a launch or an angle of a landing, we have to solve that for theta, and we can do that by taking the arctangent or the inverse tangent. There should be a button for that on your calculator, of the y component over the x component of the velocity. So please add these three to your equation card, and you can use them when problem solving demands us to break an angled velocity into two pieces.